I hope I may do justice to your words because. So thank you so much and good afternoon to you all. And the topic which is given to me, that is with the databases. So that is a very basic topic basically. So many of you must have done. So I hope I may do the justice with you all. So let me share my presentation and just a minute. So I hope it is visible.
Yes, ma'am, it's visible.
Yeah, thank you. So just to save some bandwidth, I'm supposed to switch off my video. I'm sorry. So the topic of today is database design as well as query languages. So we have two sessions today, and in the first session, I will tell you about databases, relational databases, then how to design basically ER model, and then I will introduce you the query language, that is SQL. And in the next session, we will do the lab where we will be creating a database, we will be populating it, and we will be doing some queries over there. So this whole, when we say database design, query languages, this is basically half semester long project. So, but I have tried to concise it so that I may give you something useful, I think. So let us begin without wasting our time. So, so first we'll start with the database. So now, like when you do anything, then definitely what was happening previously, that actually helps us to understand the situation. So before database systems, we are having these file processing systems, and these file processing systems, you can see that every person is having his own file of his own domain, and he's working on that. So you can say that there are, although it looks nice that, okay, I'm working with the customer application and I'm having that file. So this whole is is for one environment. So in that environment, let us say customers are there, then the suppliers are there, the products are there. But the things is that the information is lying with different set of people. Now, when the information is lying with different set of people, definitely there is some information through which you are going to connect the things, right? For example, when we are saying order processing applications, they must be having customer information. What does it mean? It means that customer information is duplicated at two places. Okay, so here there are many problems. So like, for example, this data is separated and isolated. Then, as I told you, the data is duplicated, right? Because so that, as I told you, that customer information, because order is also placed by some customer. So customer information is also there in the order processing application, let us say. This client. Now, let us say the customer says that my phone number is changed or my address is changed. Okay, so this information is being sent to the company, and let us say the file which is there with the order customer processing application, that file is being updated, right? But the same customer information which is written here in the order processing this thing, that is not updated. Now what will happen? The integrity, right? So the data, the information about one customer, but different, right? At one place, some other address is there, at some other place, some other address is there. So that is the problem with the duplicacy. And then when we are writing application program, as you can see here, they are much dependent on the file formats, right? And these files were, often incompatible with one another, right? And therefore, it becomes difficult to represent data in the user's perspective. What do we want? Like, for example, let us say if you take a simple example of a bill, then what happens? It is having some fixed area. Like, for example, you know that the customer name and the GST number of the seller and all those things, and then it is a variable. So for example, you are going there, you are purchasing 2 items, like when I'm going there, right? Maybe shopaholic or so, I may purchase, let us say 4, 5, 6 items. So it depends, right? So very simple object, but it is difficult to represent in practice. Please switch off your mic if it is there. So now with these problems, then the database processing system comes into the system. And now you can see that still people are there who are handling different applications, right? Different sort of data. But what happens here? Here you can see there is a change. Now you can see that everything is stored at one place, right? So you can see the customer data, order data, whatever data, right? All data is stored at one place. And then in between that data and the user, right, there lies a component that we call as DBMS, database management systems, right? So here you can see what difference this has made, this database system, because with this technology, right, what we did, we actually introduced, see, data was earlier also there, these processing applications were also there. The only new thing here, if you can see that, it is the database management system. This is a new component we have added, and with this new component has made our job easier. Now, how this made our job easier, we will see in the next slide. So let us say here, this is an example of university database. So we are having, okay, so if you, because this system is familiar to all of us, so we are saying, okay, let us say we are having this data. So data about course is there, data about student is there, right? Lecturer is there, whatever. Okay. Now you can see that there are so many things to be done, right? Timetable, scheduling, tutorials, all those things. Now here you can see that in between applications and this data, what sits here? Sits here this database management systems, right? Now here, if you can see that there is another thing that here, this is we call as data dictionary, right? This metadata means data about data. So whatever is the data stored here in this DBMS, how, like the information of that is your metadata, that is data dictionary. And then whether you have to execute these application program or you have to execute these queries, everything, like you can see that is being done through DBMS, right? Database management system. Now the question comes that what is database management system, right? It is nothing but a set of programs that actually process the database. Now you will say that how it makes a difference, right? In the previous setup and this setup, how this makes a difference basically. So it makes a significant difference, let me tell you. And how? Because this actually, the introduction of DBMS has made application programming much easier, right? Because now as an application programmers, we are not supposed to be concerned with the ways in which data is actually physically stored, right? And we are, as an application programmer, we are free to concentrate on the matters which are important to the user rather than the matters which are important to the computer system, right? So computer system has nothing to do with the physical how the data is stored. Okay. So as I told you that DBMS is a set of programs that processes the database. So because of this DBMS, what happens that the stored data, what is the major problem there with the file processing system? That data was not integrated. Now with the help of DBMS, the data is integrated, right? Now how does data is integrated? Remember that now, because what is happening? Data duplication, data redundancy cannot be removed at all, right? We can't expect that data redundancy, right? You can say that duplication of data should be zero. It will not be zero, right? Because we need to connect the two things, right? Two files, and then we need something common in between, right? So there will be, but still what happens with the introduction of DBMS, that data duplication is reduced, right? So whatever minimum, right, that you have to be careful. So we call it basically controlled redundancy, right? If some redundancy is there, means some duplicacy is there and you are not aware of it, right? So it is an uncontrolled redundancy. So if the data, if my DBMS is not aware of it, then it is an uncontrolled redundancy. But if the redundancy is there and the DBMS is aware of that redundancy, it is controlled redundancy, right? So when we go for database systems, there the redundancy will be there. It can't be zero, but it will be controlled redundancy, right? Now, because of controlled redundancy, what happens that if my DBMS knows that this information, like for example, if you take previous example, okay, customer. Now here you can say, okay, the course information. Okay, so if it is, let us say this information is stored in multiple files and it is a controlled redundancy, so my DBMS is aware that this thing is duplicated. Okay, so if I will make to do changes at one place, DBMS will automatically update it at other places. It is not like this that we are having, okay, the customer has sent some information. So customer processing clerk, he was very punctual, right? He was very meticulous. So he has changed the address. But let us say order processing clerk, he thought, okay, he has put it, okay, I will do it after 1 hour. And you know that time never comes. So he just forgets. So there is a lack of integrity. But here what is happening? No matter, just to maintain the system, if the information is repeated at n number of places, 50, 100, right, no matter, right, but still DBMS is aware of it, so it will be taken care there, right? So that is how and by putting some validation checks, you can ensure data integrity. And as I told you that now with the DBMS, you are not your job becomes easy. Why? Because we are saying that you are not supposed to concern with the how data is physically stored, right? So and it also eliminates the program dependency on the file formats, right? So you are not supposed to copy the entire file structure into your application program, right? And here you can very complicated objects can also be represented in much easier way, right? So that is how it makes sense. Now, let us talk more about the database. And so database management system, as I told you, there are programs basically for various purposes, right? So if you want to interact with the database, so if you just a minute, just go to the previous slide. So if you want to interact with the data, right? Anyone who want to interact with the data, you can see that it can be done through DBMS only. So no matter who is accessing it, sending requests to the DBMS, and DBMS takes care, right? Takes data, gives you, or you, if you want to store data, it stores you. So you can see that here in this figure also, if anyone who wants to access this database, it can be done only through DBMS. You can't access it by passing DBMS, okay? So now, so let us understand more about the database, because later part we have to do the queries also. We have to design the database and then we have to retrieve the data as per our requirement. So what is a database? Now here, I showed you in the previous slide that there is data dictionary, metadata. Now, how it is important. So that is what we will understand now. So a database is a self-describing collection of integrated records. Now, if you carefully look at this definition is having two parts. One part says that a database is self-describing. That is the first part. Okay. Second part says that a database is a collection of integrated records. Right. So what does it mean basically? Let us understand. So first, your database is self-describing. Self-describing, as you know that their data dictionary is also there. So you know that the data is there along with the database. The description of that database, that is also there. Okay. So description of its own structure. For example, you are saying university database. So what is there in the university database? How this university database is arranged? Everything is also there within this right data set. So we are saying that this is this description of its own structure. Various words are there. You can use any one you like. So data dictionary is there, data directory is there, metadata is there. So whichever you like. Okay. Now, this is just like a library. So in the library, what happens that we know that the books are there and then a catalog is there. So just by looking at the catalog, you come to know that whether this, whatever book you want, whether that exists there or not, right? Or what type of books are there, right? So this is similar to that. And because of this data dictionary, how it is important that it actually promotes the program data independence, right? We don't want the program to be dependent on how the data is stored there, right? So how this promotes the program data independence? Because now it is possible for the DBMS to determine the structure and content of the database by examining the database itself. So please remember in the next session when we will create the database, let's see whether you are able to see what is there in the database. So please ask me at that time if I forget. So we can always determine the structure and content of the database, right? And in case, let us say if the structure of the data in the database changes, right? Then we need to enter that change into the data dictionary, and only those programs that are processing those data items, they must be changed. For example, let us say pin code. Okay, so pin code field is updated from 6 digits to 9 digits, for example. So it means that suppose this is in the customer file. Okay, in the customer file there is a pin code. Okay, so this pin code field changes from 6 to 9. So there may be various application programs written on the this customer file, right? But a few are only using pin code. Earlier, what happens then if the no matter whether the program is using pin code or not, this whole file structure has to be given there. But now the structure is given in the not in the program, but in the data dictionary. So in the data dictionary, you are supposed to modify that, and then only those programs which are processing that, right, which are using that pin code field in some manner, then there only you are supposed to make a change. So this is how it promotes data independence. Now the second part of the definition. A database is a collection of integrated records. Now, what does it mean? Now, if you remember, I hope you all remember the standard hierarchy of data, right, which we do in the first semester. So like we say that, okay, we are starting with bits, okay, or you can say files made up of records made up of fields are in bytes and bits. So bits to files, that is the standard hierarchy of data. But when we say database, right, database contains somewhat more than the files of the user data. Not only files, there are many other things, right, in the database. You can say metadata, that is your data dictionary. Then indexes, very important, right? For example, when loads of data is there, lot of data is there, but we want fast access to the data, right? We want that when we want to retrieve some data, we should get it very quickly. So for that, what happens that, and you know that we are storing data on the hard disk, right? Database is there in the hard disk. So accessing hard disk, right? That takes time, obviously. So what is done actually, you must have heard of sorting. But here, so in the sorting, basically what you say, you are arranging items in some order, right? Descending order, so that the search becomes faster. Now here what we do is that we do not, because we know that shifting the data on the hard disk, that is a time consuming process. So let us say we are having 10 customers, right? Okay, some customer lifts and let us say some joins, and in between you want to insert, then you need to make room for it, right? That is a very costly process. So we don't go for this. So let us say your data is stored on the database, like wherever, right? Some record here, some here, some here. Okay. But what happens that we can create various indexes on this data. For example, if I say that this data is arranged on the basis of our mail IDs, right? Or if the data is arranged on the city we lived, data is arranged based on the, let us say, some other property. Okay, so please switch off your video, Dr. Rajiv ji. Okay, so here we can say that the physical location of the data doesn't change. What we do, we create indexes. So maybe based on the indexing on the cities, right? Jabalpur comes, let us say, after Indore, right? So if we are going to do this indexing, then someone living in Jabalpur will come first as compared to me. But let us say if I'm arranging it, let us say on my name. So maybe I will come first, like I will come before anyone whose name is starting with the letters after P in the alphabet, right? So we can create multiple indexes so that depending upon now these things are to be fine-tuned. So when as an application programmer you saw that, okay, on this attribute we are going to the searches are more, so you can create index on that. Although of course managing indexes, this is also a heavy task, but it's still, yeah, it has to be done judiciously, right? Then we have application metadata, the application programs, whatever information is there. So you can see that database is a collection of integrated records. Several things are there. Okay. Now let us see the simplified views of a database. So database is nothing but you can say that a database system, it is a computer-based record keeping system. Now here you can see that there is the four components are involved. Data is there, hardware, software, and users, right? So here you can see that this whole is your data. Now surrounding this data, you can see this safety wall is there, right? That is your DBMS. Now that you can execute application programs which require data from this database, or there are end users who can directly write queries on this database. So no matter, you can see that everybody who want to get access to the data, he has to go through DBMS, right? So we have here data. Now to execute this whole thing, right, you need hardware. Then DBMS itself is a software, and of course, I mean, this whole thing is because of users, right? So this is your simplified view of the database system. Now, when we talk about existing database systems, so big commercial database vendors are there. For example, Oracle is there, right? Who actually, for quite some long time, right? They actually they were the king, you can say, right here. So Microsoft SQL Server is there, IBM is there, DB2, right? Then Sybase. But there are some open source database systems are also exist, that is PostgreSQL, MySQL, right? So today we are going to work with MySQL in the lab. So now this was a short introduction because we don't have much time actually. So now we come to the data models. Now, when we say that data models, let us talk about three categories of data models. So one is the high level model. High level model means just from the user perspective. And for example, how we look at the thing. For example, in the universities or in the institute, we say that, okay, so we all know that the teachers are there, the students are there, then the non-teaching staff is there, then the classes are there, right? So we know that, okay, the information about student is to be stored, information about teacher is to be stored. Now, when we are storing information about teacher, then these are the attributes we will take. And then we need to create relationship between student and the teacher, that, so, okay, if I am offering, let us say, some course, and as a student, some student has registered for that course. So through that course, we are connected for this semester, right? So the relationships. And we do this with the help of ER diagrams that we will discuss today. Then we have low level, that how your data is stored in the computer. So basically this is for for physical data model, right? Where we are concerned with what is the format of the record, access paths, ordering, all those things. So this is, how data is stored in the computer. Then there is representational or implementation model that is meant for the end user, right? So here we can implement this model directly into the computer. For example, relational data model, that is what we will talk next. So next we'll talk about, first of all, relational data model, and then we will talk about ER diagram. And so we are having actually earlier models before relational, we were having network data model and hierarchical data model, but because of the complexity, right, of arranging data and then writing, because see, here you will appreciate when I will tell you, and many of you must already be knowing, that the way data is arranged in the relational model is a very simple way, right? Table. So when you are arranging it in a simple way, definitely the programs which are manipulating that data, they are also simple, right? But if you call about hierarchical and network model, when your data storage is somewhat complicated, links, right, are there. So naturally the writing of the application programs on such data becomes difficult. Okay? So these are the outdated models. So now this is the example of a university database. So here we can see that this is now from the high level thing, right? So we say that this is the database schema. So we decide, okay, there will be information about a student, and what information we want to store about a student. We want to store his name, we want to store roll number, we want to store his level, what course he is studying. Similarly, let us say for course, we want to store the name of the course, code of the course, how many credits are given to this course, as well as which department is offering this course, right? Because many times the courses are offered by different departments. So this is how we have decided, okay, we want to store these things and data about these things, and these are the attributes we want to store. Now here you can see that now once we decide that this is the way, this is how we are going to store our data, then we are going to fill data into it, right? So after inserting data, after popularizing these tables, right, you can see that this is what we call as DB database instance. So you can see that in this university, these are the courses. So you can see the course, for course we want to store. So there are 4 courses with the different name and code. They are having credits as well as department which is offering. Similarly, here you can see the student. They are storing, okay, student is of roll number, name, which year or label, you can say, or what is its field, right? So this is the data you have inserted there. Now, what is the distinction between schema and instance? Now, see, the schema, you work in the beginning, right? And once, so that is why it comes, it is in the designing part. So once you have designed, then you don't want to change it every other day, right? You do not wish to fiddle with the design every day, right? Unless until some policy changes in your organization, or in which you are, I mean, you need to develop, then you need to do. Otherwise, we prefer not to change this schema frequently. So DB schema changes very infrequently. But when we talk about instance, it changes very, very frequently. For example, every semester, I mean, we are offering new courses. Every year, new students are coming. The final year students are going out. First year students are coming up, right? So here you can see that instances, very frequent changes are. Okay. Now, if we talk about the relational model, then I mean, long back, 1970, it was proposed by Code, which was, and while he was working with IBM, and but the first commercial system R, that comes in 81, 82. And now, as I told you earlier, also many commercial as well as open source products are there, and it is a dominant relational model is dominant for developing the database application. So here, now when you have created database, now you need a language so that you can retrieve the information which is stored in the database. So first thing is that how you are going to create the database, how you are going to insert the data in the database, how you are going to control the data in the database, how you are going to retrieve there, right? So all those things, for all those things, you needed some programming language, right? So here we have SQL, right? It is written SQL, its name is SQL. Right, so there are several versions. So here in the SQL, I mean, we can do all tasks related with the database by using appropriate SQL statements. Now, nowadays, many of you must have heard we are having no SQL data models, no SQL data models. So here these models emerged lately, and now what is happening? The cost of storage, right? That is drastically decreasing. So now it is possible. So we don't need to store data in this fashion, right? How we are storing it here. So there are many of you must have gone through also this MongoDB or DynamoDB. But today's is, I mean, here discussion is mainly on the relational model and the database design. So when we say, as I told you, the relational model, data is organized as well as stored in the 2D tables, right? And which we call as relation. Just a minute. Okay. So data is organized in the form of a 2D table, which we call as relations, right? Okay, so relations are nothing but flat files. And so what we can say, relational database is actually a flat arrangement of data. So this now, what goes in its favor? Basically the tabular representation, because we know that tabular representation is the most natural way to represent the data to a non-programming user. So when in our daily life also, we try to arrange data in the tabular form, right? So that is there. So in fact, what happens, what is observed that you will also see there, any representation can be reduced to a group of 2D flat files with some redundancy. Remember, that is why while I was telling you DBMS, I told that there is controlled redundancy. We don't have zero redundancy. Why? Because some redundancy is required, right? So by using that redundancy, any representation can be represented in the form of 2D flat files, right? So now remember, the tables must be set up in such a way that no information about the association between the data items is lost. That is very important for to consider. So now let us see what is this relational model. Just a minute, if you give me a few seconds. So as I told you, these tables are rectangular arrays which can be described mathematically, right? So these, let us see how we are saying that these are arrays and they can be described mathematically. So you just see this table. This is a 2D table, right? Let us say this table is of aircraft model where you have this various attributes, type, then model, category, manufacturer, engines, right? And I mean, so many other attributes, right? Whatever are required. Now let us see what are the what are the properties which are supposed to be followed, so that this is a this table is actually a relation, right? It is a defined mathematically. So here you can see that so this is your row. So tables, you know that in the table there are rows, there are columns. So here you can see that row and column. Then every column, right? We say like in the file you have records. Records are basically rows. And then in each row, in each record, you are having field, right? So field, here you are having these columns. Okay. So every column, remember that these tables are column homogeneous, means that let us say we are saying if it is a manufacturer column, right? So whatever data type you have decided for this manufacturer, only that data type, right? That values will come here. It is not like that you can write here 10, 20, then Airbus. I mean, depending upon you are choosing the data type. So same sort of data will appear in a column. So they are column homogeneous, right? Then there is uniqueness of rows and column. What does it mean? Remember that there may be various columns. The order of column is immaterial. But I mean, you can take roll number first, then name, or you can take name first and then roll number, whatever you wish. But remember that all column names must be unique, right? That is why. So it doesn't allow if you want to take these 4 columns with the name engine, it will not, right? So and then also each row must also be unique, right? So here you can see that if we are saying, okay, these similar rows, right, same, right, they are not allowed, right? So same, if one row is already existing, the second row with the same data, right, that will not be allowed. So rows should be unique, right? Column names must be unique and rows should be unique. Now you can see that we can say that table relations are mathematical object. How? A relation is nothing but a set. These rows are nothing but the elements of the set. Now we know that in the set, each element is unique. So here also in this set, right, the table in relation, rows are nothing but the elements of the set and each element is unique. Okay, so this is how we are saying they are mathematically represented. Now, as I told you, the order of rows and column, that is actually immaterial, right? So, I mean, if you are doing unordered retrieval, it may also, you can also create table in different, whatever order you wish to take, and in whatever order you may address, because as I told you, the physical location is not being changed. It is the index file which is being changed, right? In the index file where I am appearing, right? Whether before you or after you, right? Like that. So when you are, unless and until you want some ordered retrieval, you want, okay, I want this column first, then this column, then this column, then, I mean, you need to tell it. Otherwise, maybe any order. Now, see the data here, again, the data is in different tables, but now that data has to be relate, right? Because as I told you earlier, the customer, the order file is there, where the order information is there. But who has placed the order? Customer has placed the order. So there must be some linkage of this order file with the customer, so that we come to know that this order is of this customer. Okay. So now here also we can see the 2 tables are being given. So one is your aircraft model, right? This is there, and another is your this manufacturer, right? Now you can see that how they are connected. See here, there is an attribute MID. See here, manufacturer ID, right? And here there is an attribute manufacturer, right? So you can see that whatever manufacturer are existing here, one of the manufacturer will appear in this manufacturer column, right? If some manufacturer who doesn't exist, obviously, how can it come? He can supply this aircraft model, right? So this is how. So just by taking the attribute in the other table, the tables are being linked. And that is what we say that some controlled redundancy is there. Okay. Now here you can see that in one table, it's In the aircraft model, the name of the column is manufacturer, right? But in the manufacturer table, name of the column is MID, no problem, right? So this is all, I mean, the only thing is that you need to tell DBMS, right? The manufacturer column is getting its values from the MID column of the manufacturer. Once you will tell it, then no problem, right? DBMS will take care of it. So if I summarize this relational model, basically in the relational databases, all data is stored in the tables, right? Tables are structured in rows and columns. So horizontally, we call it rows. Vertically, we call it columns, right? And remember that fields may or may not contain data, and data in the field is considered atomic. So this is one of the very much important requirement there. The data should be atomic. Right, we cannot write a set of values as a, for example, when we say we are saying color. Okay, so color doesn't mean that I'm writing a set there, red, blue, green, right? No, there should be one atomic value. Okay? We can't write a group of values as a value of an attribute, because now this has become the basic condition of it being a relation. It should have, every attribute should have atomic values, right? And then, for example, let us say you don't know some attribute value. For example, let us say you need to write, let us say Neha is creating this a data set for the information about these speakers. Okay, so let us say she has to write this attribute age, but she might not be knowing my age. So what she can do, she will not write 0 there, right? Because 0 is a value here. If you don't know some data, right, some data for some field, then what we need to write here, null. Right. So let us say she's not aware, right? What is my age? So she can write null over there. Right? So then, as I told you, the column names of a table must be unique, and all rows of a table should be different. Okay. So like order is not important. Okay? If it is important, you need to mention it, and the DBMS will do accordingly. Now, when we talk about relational model, another important thing for us to consider, that is keys, because we are saying that each row is unique. So how the system will do that? Okay, because let's say there are 1,000 rows already in a sum table, and I want to insert a new row there. So how is it possible to check that this is different from the previously stored rows? So for that, we need to tell DBMS certain trick, right? So that it may check that if that row is existing or not. So if it exists, DBMS should deny automatically that this can't be inserted. Or if there is no redundancy, right, it is a unique row, then the DBMS will automatically insert it, right? So this whole thing depends upon, is established on the concept of keys. So now we know that when we say that every row is unique, right, that is there. It means that combination of all attributes is having the unique identification property. But in general, what happens that some subsets of attributes, they also have this unique identification property. So that is all such subset of attributes, they are called super key. For example, one super key is, let us say I'm having a relation, okay? The student ID, student roll number, student address, okay, student phone number. 4 attributes are simple. So naturally, if I'm taking these 4 attributes, all rows are unique, because that has to be followed. So it means that this subset of attributes, 4 attributes, they are giving you uniqueness property. Now let us take out phone number. We are having only 3 attributes now: student roll number, student name, as well as student address. But still we have uniqueness property, right? This is another super key. Now let us take out address and insert phone number. So now again we have 3 attributes: student roll number, student name, and phone number. Still we have uniqueness property. So this is another super key. So all subset of it, like let us say we are having a student roll number and a student name. Again, all rows are unique. So this is another super key. So all subset of attributes on which the relation is following this unique identification property, these are all called super keys. Now let us say if I am taking if I am dropping the student roll number and student name, and I am only keeping address and phone number. right? It might be possible that two students might be living in the same place, right? So it is not having this uniqueness property, though this is not a super key. Okay, so any subsets of attributes in a relation which has the property of unique identification, these are called super key. Now what is a key? So the minimal super key, when see in the from, let us say we have taken these 4 attributes as a key, we have taken out phone number out, is still the uniqueness unique identification property is there. Now we have taken address out, still we are having student roll number is student name, so uniqueness property is there on the rows. Let us say we take out name also. Okay, now only student roll number remains. Okay, so that is the minimal super key, because we know that every student is having a unique roll number. So based on the roll number, all these rows are unique. Okay, so this is basically we call minimal super key. So all those super keys, right? See, whatever attributes you are taking, and if the roll number is included in that, all those will be super keys, right? But we are where what is happening, this uniqueness property is there because of, mainly because of roll number. Okay, so we want that. So that is why we are saying that the minimal super key is the key. So from the super key, just remove all those attributes, right? So because why? Because we want a key that is non-redundant, right? So that has to be chosen carefully. So key is, always remember, key is minimal super key. Now, when we say we are having keys, for example, here in this, we say, okay, in some class, roll number is also having this unique identification property, and the name is also having unique identification property, and both are one single attribute. You can't remove anything. So here what is happening, when we are going for minimal super key, we are having 2 keys. One is your roll number, another is your name. So 2 super keys are there. So what we'll say that, we'll say that here there are 2 candidate keys. So roll number is also a candidate for key, and name is also a candidate for key. So there are 2 candidate keys, and out of these 2 candidates, we will choose one as a primary key, or you can say the minimal key, which we call as a, which we use as a primary key. Now what happens? So out of roll number and name, one we have chosen as the primary key, but still you know that this property holds there. So let us say roll number we have chosen as a primary key, but student names are also unique. That is also exists, right? So that we call as alternate key or secondary key. So out of all candidate keys, we can choose one as a primary key and the others as a secondary key or alternate key. For example, in the car, there is a number plate, right? So we know that just by looking at MP something. So we know that, okay, this vehicle is registered in Madhya Pradesh, and then some number is there. So that state and that number, that uniquely identifies your car. But so that is visible to everyone. But if you those who are interested in there, they must know that there is a engine number and chassis number. So every car is having an engine, right? So engine number and chassis number, that is also a unique. Right. So here for the car, let us say we can choose vehicle registration number, or you can see this engine number and chassis number, both. Like, so 2 candidates are there. One will be chosen as a primary key, the other will act as a secondary. Now here, so we said, okay, first of all, primary key. So you can see that this is a table, aircraft model, right? So we need some attribute with which we can identify aircraft. So we are saying, okay, what is the type of the aircraft? What is the model number? And then there are remaining attribute of the aircraft, length, height, whatever, wingspan, net weight, whatever. Right. So these are the primary key. Now here you can see that in the previous example, what we talked is student roll number, right? Single attribute, right? That is your primary key, minimal super key, primary key. But here your minimal super key is not of one attribute, but of 2 attributes, combination of attributes. Like I took the example of vehicle registration number, right? State plus the number, or you can say engine number and the chassis number. So this type of primary key we call as composite primary key, right? Not one attribute, but the combination of 2 attributes serve as a primary key, right? So this is then the other attribute, okay, primary key. Now let us understand what is foreign key. Now you can see here, there are two tables. One is your aircraft model, another is your aircraft, right? Now in the aircraft model, you can see this type code and model number. The combination of these two attributes is the prime, right? Now there is another table, aircraft. In this aircraft, this you can see that this type code and model number are being used. But this type code and model number, they are the primary key in this table. So this table is called parent table. And here you can see that type code and model number, they will get its value from this table, main table, right? So this parent table. So this is your child table and this is your parent table. Now you can see here, this is how we are saying, okay, this is because this type code and model number, they are being taken here. So this is your parent table and this is your dependent table. What does it mean, dependent table? Why aircraft is a dependent table? Because aircraft is having two attributes here, type code and model number, which are primary key here. Means that if some aircraft is there, so you can choose only that model which is the existing one. So if let us say some model here, if I want to insert here a row, let us say where I'm saying C120 and 100, right? This cannot be inserted here with other fields. Why? Because C120 doesn't exist here, right? So this is a child table and whatever value will appear here, that should be appearing. If something means the child row cannot exist without a parent. For child to exist, parent must be there. Okay, so this is called referential constraint, right? Because this table, these attributes are referred here. So this is these two attributes, type code and model number, they are the foreign key in this aircraft table, right? So this type code and model number, that is the primary key here, and this the same, right? Type code and model number, they are the foreign key here, right? So this is parent table, this is child table. Now let us say here, suppose length of the model. For example, let us say we have also taken here length of the model. Okay, but length of the model will not be foreign key. Remember, in this table, a type code and model number are foreign key. But why? Because these type code and model number, they are the primary key. If let us say, for example, we take length of model here, then length of model will not be foreign key, right? Only these two will be. Now take another example of foreign key. Take this aircraft table and this engine table. Okay. So here, if you look at this column, this aircraft number, see this aircraft number, and here this aircraft number. Okay, now what happens here, the aircraft number is the primary key in the aircraft, and so that aircraft table is the parent table, and engine table is using in engine table, what is primary key? Primary key is your engine number, right? Or let us say engine type, but aircraft number here is there, and that is the foreign. Okay, now foreign key may be, like in some table, foreign key may be part of the primary key in the, let us say, for example, in the engine table. But any attribute to be foreign key here in this table, it must be primary key in some other table. So what is happening here? Remember, when we are writing aircraft number, so either it will take any of the existing value here. It cannot take any value out of it. Okay, but suppose we don't know, for example, when we are entering data, then we don't know what is the value here. So what we can write here? We can write here null. Okay, so that the value exists, but we don't know what is the value. Okay, so this is how we understand foreign key. If there is any question, you may you may drop a passage. Now, how we take care of referential integrity? Okay, so we are having several rules there. So, for example, insertion. Let us say this is your parent table and this is your child table, right? So, and these two attributes are being referred here. So, if I want to insert some row in the aircraft table, no problem. We can always able to insert it as long as this is a unique row, right? Unique there. Now, let us say if I want to insert something in the dependent table. For example, if I am inserting this row over here. Okay. So this insertion is possible, right? But this insertion fails. Why this insertion fails? Because this A300, you can see this A300 and 600, that doesn't exist here. You can see here, A300 doesn't exist here. But this B737, you can see that this B737 exists here. So that is how we can insert this new row into the aircraft. But we can't insert this row, right? Why? Because this A300 doesn't exist here, right? So that is, so while insertion, we need to follow this so that the insertion, yes, you can store, no problem, in the this. Then what about how do you ensure that, because we said that data integrity, very important to understand this word, that data in the database should be correct. Okay, so for example, let us say if we allow this insertion in this table, then what happens that some child exists but parent doesn't exist, which is not allowed. Okay, so now see what happens in the deletion. So again, these are the 4 tables now. So here, let us say this, these attributes are referred here. So this is your foreign key, right? These attributes are foreign key. Similarly, this aircraft number, this is a foreign key. Okay. Similarly, this aircraft number, this is also a foreign key. Now, suppose I want to delete this row here. Okay, A340. If I want to delete this row here, what are the possible ways to delete? Now, what is happening? If I want to delete this A340 here, but you can see that here this A340 200 exists. So if I will delete this row here, then what will happen? This row will become orphan. This will become a child without a parent. So this deletion is not allowed. Means that if some parent is having a child, it should not be allowed to be deleted, right? What is the way to delete? First of all, you delete this row from here, and then only you can delete this row from here. Okay, so not allowed. This is one solution. Now, another solution is that what? Let us say I want to delete this B47 for, okay, this one. Let us say I want to delete this here. But you can see that this is existing here. Right, this is existing here. So what we can do, another solution is that here we can write null. So another option is set null. So on deletion, set null. Okay, so on this NA means restrict. On what is the policy? Policy is restrict. So if some parent is referred in some child table, then that parent row cannot be deleted. Set null. So if the parent is deleted, then in the child row, the field is set as null. Now another is that cascade. Cascade means what? That let us say if you are deleting some parent, right? Parent row, then automatically the child row will be deleted. Okay. So there are 3 options. So no action means that this can be changed only if the dependent table does not have any child, right, on that. So restrict, set null, and cascade. Cascade means that like if you are deleting some parent, the child row will automatically be deleted. So usually we don't go for that. So most of the system, they support basically no action or restrict. They are the same thing. So by default, when you will choose SQL, then by default, the choice is restrict, because if you cascade by mistake, you have deleted something, it will be a long repercussions. Okay. So remember always these update rules. Now we will talk about, so any question till now? Okay, so let us continue. I believe that many of you might be, must be aware of these things.
Hello, madam.
Yeah.
Ma'am, this is Narayanan. Actually, in the slide, in one of the slide, you have mentioned were 2D tables like. So what is mean by the 2D tables?
2D basically, you can see row and column. This is 2D.
Oh, like, okay, fine.
2D, yeah. See, this is 2D. Row and column. Okay. 2-dimensional table.
Acha. Okay, thank you. Thank you.
Okay, so if there is no other question, then let us move. So, I would request you to understand this part carefully, because how the integrity rules, because that is very important. Now, how to model your data. So let us take this overview of your database design. So now there is a conceptual design, right? So there, that is what we say high level. Okay. So here we decide that what are the entities and relationships in an enterprise. For example, when you go for university system, you say that, okay, faculty is an entity, student is an entity, and then what is the relationship between a student and the faculty. And so once you decide what are the entities, you will decide what are the information, right, about these entities as well as relationship you would like to store, right? And that what are the integrity constraint, like this integrity constraint we discussed now. For example, the differential integrity we talked about. And then, but remember, in the we are also having this see, remember we talked about primary key. So remember that no part of the primary key should be null. If your primary key is a composite key, let us say, then no part of the primary key should be null. So that is the integrity rules, right? But there, apart from integrity rules, there might be some business rules. Business rules, for example, in our institute, let us say retirement age is 65, right? In some other places, there might be an institute where retirement age is 60. So these are called the business. For example, a student is having these many casual leaves in the semester, these many medical leaves, right? So you need to see that, like if the attendance is less than, let us say 75%, the student will be not allowed to sit in the exam. So this is an example of the business rule. So you need to know what are the business rules in that organization, and you need to see how can you implement those business rules, right? So here for conceptual level, here we use ER model, right? So here the database schema will be represented in the pictorial form, which we call as ER diagrams. And although today we will not discuss, but you can go through it. And this we can map ER diagram into relational schema very easily, right? So what is entity, first of all? So entity is something, some real world object that is distinguishable from the other objects, right? So here you can see that employees is an entity, and it is described using a set of attributes. For example, here we are saying, okay, employee ID, name, and lot. Okay. So now remember here that when we say entity, real world object, it doesn't mean that living object. For example, some amendment in the in our constitution, right? Some job type, right? These are also maybe entity. Okay, entity doesn't mean that it should be a living object. Okay, now what is entity set? Entity set is nothing but a collection of similar entities. For example, this organization is having 100 employees. Okay, so each employee is represented by one row, right? So each row is a employee, right? And the collection of all those employees, that is your entity set. So all entities in the entity set, they must have same set of attributes. So every employee, so whatever attributes we have decided, right, every employee will have those attributes, right? And each entity set will have a key. That is what we are storing by underline, right? And each attribute has a domain. Domain is what? A pool of values from which an attribute gets its values, right? That is your domain. Now relationship. How relationship is nothing but the association among two or more entities. Now, if let us say this is an association, here you can see that association between two entities, employee and department. So this is a binary relationship. If a relationship is involving three entities, it is a ternary relationship, and like that. So what is happening, or if some entity is related with itself, that is a unary relationship. So, but in reality, what happens that we don't go beyond binary because it becomes difficult, right? In some cases, ternary relationship, we try to see that if we can represent some ternary relationship also via binary relationship, right? But we mostly go with binary relationship. So now, so we say, okay, relationship here, employee and department. So we are saying that what? Let us say Aquino is some employee who is working in pharmacy department. Okay, so that works in. Okay, that is a relationship. So employee works in department. Okay. So here you can see that these are the attributes of employee. These are the attributes of department, department ID, department name, and what is the budget of this department. And this works in. Now you can see that as entities may have attributes, in a similar way, relationships may also have attributes. Now, attribute, this decides. Now, when we say works in, so when we say that Aquino works in pharmacy department. Okay, since when? Okay, so that is the attribute of relationship. Okay, so what is a relationship set? Again, if we collect similar relationships, so A works in department D1, B works in department D2, C works in department D1. So if we collect all those and all those instances, that is your relationship set. Now, as I told you, sometime what is happening, a table, entity can, okay, table will come later, basically entity here. So an entity can refer to itself. So here you can see employees. Now, in the let us say here employees. So let us say if in our institute, let us say head of the department. Okay, so head of the department is also employee here. I am a faculty member is employee here. Head of the department is also employee here. So head of the department is above us. Let us say we have to report to head of the department. Now, head of the department is supposed to report to director. The director is also an employee. So here you can see that employee table is referring, right? Or employee entity is referring to itself. So here you can see that one employee, let us say who is head of the department, is supervisor of a faculty. Or let us say one employee, that is director, may be supervisor of all other faculty, right? So here you can see that employee is participating. There is a relationship reports. Now, employee is participating in two roles. One role is the role of supervisor, let us say head. One role is the role of subordinate, that is, let us say, an ordinary faculty there. Okay, so that is a unary relationship. So here you can see that when you will convert this into a relation, what will happen? You will have here SSN. In the table, you will create a table for this employee. So SSN will be the key of that table. And here, for how do you connect one table with other? So here you are taking another attribute. Let us say super SSN. Super SSN is the ID of the this employee who is in the managerial role or supervisor role. And see, the one who is employee, only he can play the role of supervisor, right? If let us say my ID is 05, okay, and here my supervisor is 50. So 50 must exist in this data set, right? In this table. Otherwise, 50 can't appear here. Okay, because he must be an employee for if he has to be my supervisor. Okay, so the super SSN, whatever values which are coming in this column, they are taking its values from the SSN column. So SSN is the primary key here, and super SSN is the foreign key here. So a foreign, it doesn't mean that foreign key always comes from other table, right? Sometimes foreign key may come within table, right? So here this super SSN is the foreign key, which is referring to the primary key of this table, which is SSN, right? Now, there are many constraints on the relationship type now. So first is cardinality ratio, that is the maximum participation constraint. So this specifies maximum number of relationship instances that an entity can participate in, right? So one to one, one to many, many to many, many to one, many to many, like that, right? So let us see how we do this, how we set this. So we'll do that. Okay. So next set is participation constraints, that is minimum participation. So what is the maximum participation? That is cardinality constraint. What is the minimum participation? That is participation constraint. So sometimes this participation may be optional, right? Sometimes this participation is mandatory, right? So either if it is optional or it is mandatory. So we'll see how to represent it. Now take this example, and then we are going to put it our cardinality constraint and participation constraint into. So here you can see that works in is a relationship. Works in is a relationship between employees and departments. Okay. Now consider how employees and departments are participating in this relationship. See, read it, the condition here. Condition says that each employee works in one department. Means an employee cannot work in multiple departments. Okay. And a department can have many employees. Now, what does it mean? An employee works in one department. So, and a department can have many employees. See. So we need to know what is to be done here. So from employee side, it is one, right? From department side, it is many. Okay. So it is basically a one to many or many to one, you can say. So here you can see that in one department, many employees works and many employees works in one department. Now you can see that an employee works in a department. So the participation of employee in this relationship is total. How this is total? Because if I am an employee here, so I'm joining in the CSE department. And so if I'm not, so that is the condition here. So we are saying, okay, as soon as the employee joins, he is given the department. Then the participation of employee is total. Let us say some other company which says that, okay, let the employee come, and then he will go to the different departments and will find where he will suit. In that case, participation of employee will become partial. So partial participation is denoted by single line and total participation is denoted by double line, right? So this is how. Now take another example so that we can understand it better. So if you consider another relationship, this is manager relationship here. And here that this is the relationship between employees and department, right? Now see, it says that each department is having one manager. And who is the manager? Of course, one of the employee will be the manager, right? And an employee can manage at most one department, right? It means that a department cannot have more than one manager. An employee cannot manage more than one department, right? So what will come here? This relationship. Earlier it was one to many or many to one. Now this is here one to one. Okay. And what about participation? We are saying that each department must have one manager. Matlab, what is the participation is total. There is no choice, mandatory, right? So this line should be the double line. But employee can manage at most one department. It means employee can, because it is written can, right? Can manage, cannot, right? More than one. So it means that employee may manage a department, may not manage a department, right? So every employee is not a manager in any organization. So here this line, this participation of employee in this relationship manager is partial. So this line will be the single line. So how do we represent here? This, you can see participation of department is total, participation of employee is partial. Now, one department is having one employee will manage at most one. Right. So that is how constraint. So if it is clear, not clear, you may please ask. Okay. Now comes weak entities. What happens that sometimes certain entities are being identified by other entities, right, which are called owner entities. For example, in every like many of us, I mean, this is because this is a capacity building program, I believe all faculty members are there. So, I mean, many of us must be having, parents, of course, right? A spouse, then the children. So they might be your dependent, right? So when we join any organization, we need to declare, okay, so let us say if my parents are not, are not pensionable, right? So I have to support, or if my children are, up to certain age, they are dependent on me. So we are getting certain benefits out of it. So it means that if I'm saying that my children, so, okay, so my children, how they are being identified in the system. So let us say some medical benefit is there. We have a health center and my child can come and take the medicine from there. But in the health center, how they identify my child? They will not identify him by his name. They will identify him by my name, right? So I am the owner entity and my child is a dependent entity, right? So that is a weak entity. Okay. So here you can see that dependent is a weak entity. Okay. So it always needs some owner entities, or you can say identifying entity for its identification. So if my child comes there and say, I want to get medicine, no one will treat him, right? But when he say that, okay, I'm dependent on so and so, then he will be treated, right? So this is how the weak entities are being represented, right? Then, okay, so here you can see that, remember always that weak entity will always have total participation, because every weak entity needs one identifying entity. Without identifying entity, it can't exist. So see here, this employee participation may be partial, right? Because let us say, let us say 20 years before I may not be having any, maybe many of you are like that, very young. So you are not married, so no spouse, no children, and your parents are in the job, so they are also learning. So at this point of time, you don't have any dependent, right? So an employee may have dependent, may not have dependent. Okay. So participation of employee in this relationship is partial, right? But participation of dependent, right, that is always total. Okay. Now, say similarly, we just represented this constraint, cardinality and participation constraint. There is another way of representing constraints, right? That is your min-max notation. So minimum participation and maximum participation. Now, what we said here earlier, so works in, we have already done. So let us write it in another way by using min-max notation. So we are saying, okay, each employee works in one department. Okay. So what is the minimum there? Minimum an employee works in one department and maximum an employee works in one department, right? But here it says that a department can have many employees, right? So how we are writing here? This 1:1, right? That is minimum there. And here, instead of writing it total participation, we are writing it M:N. So minimum M. So let us say if I'm saying let us say the company is having a policy that for starting a new department, there must be minimum 5 members. So what will be this constraint written like? Let us say 5N. Or sometime this 5, N, right? Whatever. So this is your min-max notation. Now there is also is a relation to represent hierarchies. So while we are working on C++ and other programming languages, we know that attributes are inherited, right? So when we say that A is a B, what does it mean? It means that every A entity is also considered to be a B entity, right? So here you can see an employee. Now, in the employees, there may be some employees who are hourly employees, who are some maybe on the contract employees. There may be variety of employees in this, right? So this is we call as is a hierarchy. So employees, remember that whatever attributes are there of employees, all these attributes will be true for this, although they are not being shown here because there is a relationship. Whatever attributes of employee are there, all those are there for hourly employees as well as contract employees, right? Now here what we say that we will say that employee is a super entity, right? And hourly employees and contract employees, they are the sub entity. Okay. So now why we are using this is a hierarchy here? Because by using this is a hierarchy, we can add descriptive attributes which are specific to a subclass, and we can also identify entities that participate in a relationship, right? For example, maybe all employees are not participating in some relationship, only hourly employees are participating, right? So we can treat them separately. Okay. Then now here there may be when we are saying this constraint, there may be overlapping constraint, there may be covering constraint. For example, if let us say if I am saying that A, okay, some entity A now is a here B or C. So here what is happening? We can write either D or O. D is for distinctive, O is for overlapping. Distinctive means that all entities in A, they will be in either B or C, right? Or sometimes they may not be this. So what is happening here when we say this distinct, that if some entity is participating in B, then it cannot participate in C, disjoint. But overlapping means that some entity might be belonging to class B as well as class C, right? Overlapping. Okay. So, so what does it mean when we say overlapping? So we can say, okay, whether employee is hourly employee as well as contract employee. It may be possible that some contract employees are paid monthly, but some contract employees are paid hourly. So in that case, some employee X, let us say he is on contract, so he will appear in the contract employees as well as he is paid in hourly, so he will appear here also, right? So that is example of overlapping, disjoint or overlapping. Now aggregation. Now what happens that sometime we need to model a relationship which is involving entity sets and a relationship set. So here you can see that this entity set, this is your relation. This is your relationship, right? So aggregation actually allows us to treat this relationship set. This is nothing but because what is happening, remember I told you that this ER model will be can be converted into relational model. So what happens when we convert it? When we see this ER model, then corresponding to every entity, we create a table. We create a relation for every entity, right? But if we say the relationships are also represented by relations tables, because remember that when we say relational model, relation is the only structure, right? So relation, or you can say 2D table, is the only structure to represent our information. So if we have some entity, we will have a relationship, we will have a table, or you can say relation corresponding to that entity. If we have some relationship, right, then also we will have relationship will also be represented in the form of a table. Now here I will not go into the more detail, because sometimes what happens that instead of creating a separate table for a relationship, we can just include some attribute in the other relationship and our job is done. So when it is a one-to-one relationship or one-to-many relationship, we simply include attribute of one relation to other relation. But if the relationship is many-to-many, then we need to create a new table for this relationship. But anyways, relation are to be created, right? That is the only mean here. So here this aggregation allows us to treat this relationship set as an entity set, right? Which is participating into other relationship, right? So here you can see that monitor is a distinct relationship, right? With that, this is the attribute of this monitor relationship, right? And here you can see this is one entity and this is another relationship. This relationship projects and departments. So every employee is, or sorry, employees are monitoring, right? This sponsorships. Okay, so or you can say sponsorships are being monitored by employees. Okay, at most one employee. So that is aggregation. So this is all about ER model. Any question? Okay. So now come to the query language. So when we go for query language, we'll talk about structured query language. So SQL, it is pronounced as SQL. Thank you. So it is pronounced as SQL. And as I told you that it was because relational model developed at IBM, part of IBM project. So it was developed long back. And then we can say that SQL is nothing but a computer language that is used to interact with the database. So when we create data, I mean, when either you have to create database or you have to manipulate database or you have to control database, how do you do this? You will do this by using SQL, right? So this is a very powerful language, but very easy to learn. So we will learn it. I thought I will cover some, but okay, we will do it in the next class also. So now what is SQL? Basically, this is a tool for organizing, managing, and retrieving data which is stored by the computer database. Okay, so as I told you, this is a very this language is contains very a small set of statements. Although these are small set of statements, but very powerful statements. And using those statements, we can very easily manipulate and manage as well as protect our data which is stored in the database. Remember that SQL is not a DBMS, and also it is not a standalone product. What does it mean? If you go to the market and say, I want to buy SQL, you will not get, right? So it will come when you will purchase some DBMS, it will come with this, right? So it is a database language for relational database management systems, whatever I names. And remember that almost every DBMS supports SQL or a dialect of the language. For example, for Oracle, they have developed their own PLSQL. So, but some dialect will be there supported by, right? Now the question comes that why this is given this name SQL, right? So remember that whenever you need to do anything with the database, you need to tell this to DBMS. Now DBMS will inspect your statement, right, your command, and will understand it and execute it on your behalf, and whatever result is generated, that is being shown to you. So this is a very systematic process, so we call it SQL, right? That is why this is given this name. Now, this is the example database which we will take today, because I wanted to take some small data set so that you may execute it easily in the lab. So this database is containing 3 tables. One table is sellers table, another table is boats table, and then reserves table is the relationship between the sellers table and boats table. Okay. So in the sellers, we are having 4 attributes: seller ID, seller name, rating, and age. And SID is the key. In the boats table, we have boat ID, boat name, and color. So boat ID, boat name, color, boat ID is the primary key. Then we need to establish connection between relationship between sailors and boats. And that is how we have a relationship reserves, right? So reserves is having 3 attributes here. So sailor ID, boat ID, and this day. Day means date. So this sailor, what is the meaning of this row? The meaning of this row is there that sailor ID, sailor whose ID is 22 has reserved this boat whose ID is 101 on this date. Okay. So we need to create this database and then execute our queries. So I'm stopping here, but I need to tell you something, because to execute this, we need to install WAMP server or XAMPP server, depending upon whether you are working with Windows or with this iOS. Then you need to install that. So I am showing you just a minute. I am showing you a folder. I am sharing it with you. And just a minute. So just a minute. Yeah. So just see, I will share you one drive here. You can see that the WAMP server, those who are having Windows server, they can download this exe file and execute it. The instructions are given here, WAMP installation instruction. Similarly, those who are going for XAMPP server, the instructions are already given here. And yeah, I will upload that. If you are not able to download this XAMPP server, then I have done it on the upload. I will upload it. And so you can, you please, before we begin the next session, you can, you please install, right? So I'm sharing you, just a minute. I'm sharing you the address of this folder with all of you. Just a minute. So see this, try and let me know if you are able to access this drive. On this drive, the WAMP server is there. You can directly download WAMP server from there, those who are having Windows. And for Apple, XAMPP server is there. The instructions are given in the PDF file. Just see whether you are able to go to the drive folder. So before we start our next session, please get ready your WAMP server or XAMPP server on your system, because then only you will be able to execute what we are going to do today. Are you able to see? Just drop me a message. Okay. Okay. So there was one question, how security is provided. So remember that when we go for so when we go for SQL, then in the SQL, as I told you, that there is a set of statements, right? Some statements are there which are used for DDL. DDL is data definition language. By using these statements, we are creating the relations, we are creating the we are inserting the data into the database. Then there is another statement, that is DML, data manipulation language. Means when we want to retrieve data from the database, we are going to make use of DML statement. And then there is another category of statements, that is DCL, data control language, right? So in the data control language, how do we manage security of the data? Because what happens with the database, when everything, just a minute. So when everything is at one place, the security of the data becomes very important, because we all know that shared responsibility is no one's responsibility, right? So when everything is at one place, we have to be very careful. So how do we manage this thing? So what we do is that we make use of DCL, data control language. Through this data control language, we give access on different items to different users, right? So remember that one thing is that for ensuring integrity, we must take care of this integrity constraint, as well as all business rules must be implemented properly. And then we need to decide which data is required to whom. Unnecessarily, see, let us say in every institution, there is academic office, there is a student affairs office, right? Now, it might happen that the student is having some CPI there, the student affair office has nothing to do with that CPI, right? Similarly, so, I mean, depending upon or how the grade sheet is being prepared. So the access to the grades obtained by the student, grade preparation, this should remain with the, let us say, person who is working with academic office. This should not be with the person working with the student affair office, right? So we will decide that which relation should be, which the access should be given access to this user. Or even in the table also, we can say that okay, which rows may be given access, which tables may be given access, or sorry, which attributes may be given access. So that is done with the help of DCL, right? So we give access and we revoke access. So at any point of time, as a DBA, database administrator, you will see that what information is required to whom, and depending upon that, you will give permission to that, right? And once you want to, so you can give permission at any point of time, and if you feel that this permission is not required now, then that permission may be revoked also. Although I have not included this in the slides today, because actually this is too much to be covered in this small time. But if you're interested, then I will, in the meantime, I will include one statement there so that you may check it. Yeah. Okay, thank you. So we'll meet at 5.